Hi guys, I'm Michael. Welcome back. In today's video, we're going to look at how to use Python's set data type. A set is an unordered and immutable collection of unique elements, such as like lists. Elements in the set do not have to be of the same type. Just like here, this is an integer and this is a floating point. Unlike lists or tuples, there are two types of sets, sets and frozen sets. Frozen sets are immutable. That's how they are different from sets. If a set doesn't need to be changed later, using a frozen set is a more efficient option. You can create an empty set like just use the sets construction function and add elements to it later, like now fruits has a single element in it, and you can add more. Or you can create a set literal with some initial elements already in it, like the numbers set here. This is a set literal. Note that since elements in the set are unique, when you add an element that's already there, the existing elements will be overridden by the later added elements. Let's add apple again and see whether there will be two apples. So there's just only one apple. Note that you cannot add a list to a set or initialize a set with a list. Let's try. So you will see type error, unhashable type lists. So lists is an unhashable type because there can be identical elements in the list, while sets do not allow identical elements. You can pause this video and experiment declaring a set and initialize it with lists among its members, like so you can just try this yourself. Now I just commented out. And you cannot add a dictionary to a set either. You can try that out yourself. But you can add a tuple to a set, like tuple, like durian, pomegranate. Now we have more fruits. Note that the tuple got absorbed in got absorbed in as a whole element, as a single element, instead of its members getting dissolved and blended in the set. So it's an element in itself. That's why you can even add a tuple with identical elements. You can just try this out yourself. Okay. So I also comment this out and so that you can try it yourself. However, you can declare a set with lists like this. Okay, to save time, I've pre-typed some examples here. Let's try this one. Now teams become this. As you can see here, the set does not preserve the order of the lists because sets is an unordered collection. If the lists contains identical elements, only one of the identical elements will remain. For example, so here we have two casual wear, okay? And we do clothing types as a set and use the categories lists to initialize the set. And now clothing types becomes this. And you can see there is only one casual wear now. That offers a nice way of eliminating duplicates in the lists, doesn't it? You can check membership with the keyword in, like we do in lists or dictionaries. Lingering. It will return true because we can find the lingering here, okay? Unfortunately, we cannot directly retrieve an element of a set by way of subscripting like we do a list. For example, will this do? It will throw a name error. I just typed clothing instead of clothing types. Let's do this. So it will throw a type error. Set object is not subscriptable. Okay. However, there are some indirect ways to access elements in the set. One is to use iteration to traverse through a set and operate on individual elements like CT in clothing types print CT, for example. That's one of the things we can do to the elements in the set. So you will see all the elements in the set got printed out. If you want to select just the sum of the elements, you can use if statements to control the flow. Another way is to convert a set to a list and randomly access elements via indexes. For example, let's do clothing type list. We just use a list construction function and feeds clothing types to it. And this will create the lists like this. And then we can comfortably access any elements, use indexes. Okay. Or you can convert the set into a dictionary using the zip function like so this will create range 0 to 5. And then we do a dict using zip and put the range of types here and clothing types here. And now we can comfortably do this. So we can also just look at the dict. It has become this. That's why we can do this too. A caution is that when the set is very large, converting it into a list or dictionary will be memory costly and time consuming. Using a loop will be more efficient. Now let's remove an element from a set. So we can use the remove method, which removes an element from the set and returns none. Let's just remove some elements from closing types. Let's remove formal where since it's not so comfortable. Now closing types becomes this. So formal where is gone. If the element is not found in the set, remove throws a key error exception. You can try that out yourself. And a similar method is discard. Types, discard, lingering. Now, we just got a one element less since lingering is gone again. So what is different from remove is that we should use the closing types as the object. We cannot just call discard without the object. Okay. Now it will do the trick. So you can see the three elements are still there because sports shoes is not found in the set, and no error message is thrown. Okay. If you do wish to return the removed elements, you can use the pop method. Pop. And you can get a casual wear. So it just pops the elements from the front till the end. And unlike the pop method in the list class, the pop method in the set class does not take any arguments. So any methods that modifies a set cannot be used on the frozen set instance. You may wish to give it a try on this frozen set. Let's create frozen set out of a list for convenience. Now the frozen set is this. And you can try the above methods, okay, that modifies a set to the frozen set to see what happens. Okay, let's see the mathematical operations that can be done on two or more sets. These operations include union, intersection, difference, and symmetric difference. Okay, first let's see union, which combines all elements in multiple sets into one new set. Let's get some examples from here. So you can see trees and flowers. Should be trees. Yeah, now let's see plants. Okay, so you can see all the elements in the trees and flower sets got combined into the plants whole big set. And you can also use the union operator for convenience sake. Plants, trees, flowers. So plants is also like this. So what is nice about the union operator is that you can join multiple sets on a single line. Let's add one more set here, that is herbs. Now let's join them together. Let's make plants even bigger. I leave this for you to try out yourself, so I just comment out. Now let's look at the intersection option. Intersection option selects the elements that are found in all participating sets. Let's do another 2 sets. Let's do fruits and veggies. Okay, fruits and vegetables. So you can see in fruits and vegetables, there are both tomatoes, right? Okay, and cucumbers. So maybe some people regard tomatoes and cucumbers as fruits, and some regard them also as vegetables. So let's do fruity. Let's just consider them as fruity veggies. So fruits, we use intersection and we put vegetables in it. Now fruity veggies becomes this, tomatoes and cucumbers, because both of them are found in both sets. Similarly, there is also an intersection operator, fruity veggies, fruity fruits intersect vegetables. Now fruity veggies is this. And it can too be used to intersect multiple sets. Okay, the intersection operator, it can be used to intersect multiple sets. You may want to try that out yourself. If there is no common elements between sets, an empty set will be returned. Let's just do this. Trees intersect flowers. Okay, you can see we got an empty plants here. Okay. So the difference between set A and set B is the set of all elements that are found in A but not in B. So let's see just fruits. And now you got the pure fruits here. That's peaches, apples, bananas, and tomatoes and cucumbers are gone because they're also in vegetables. So we find the difference. And we can do vice versa. Vegetables. Difference. Fruits. And just veggies now is this. Pumpkins, tomatoes, and eggplants, and without fruit, tomatoes and cucumbers, okay? The difference operator is the same as the mathematical minus, okay? Is that funny? Vegetables, that's right now. Just fruits. must have used this too. Vegetables minus fruits, and just veggies is this. Okay. And the symmetric difference of set A and set B is the set of elements that are in either set A or B, but not in both. We can do just fruits and just veggies. So that's symmetric. Difference. Vegetables. And now just fruits and just veggies is this. So you can see it gets the elements that's only in fruits, and the elements only found in veggies here combined, without tomatoes and cucumbers, which can be found in both. And the symmetric difference operator is a caret symbol. So let's do just fruits and just veggies. We got fruits, vegetables, we got the same. You can check if a set is a subset of another with the is subset method. Let's do smartphones and smart devices. Okay. Okay, smartphones, you have these brands and models, and smart devices, including more. Okay, that's a long list. So all these elements are not, all these examples are not intended for advertisements. So now you can do this. Is subset smart devices. It returns true because all these elements can be found in smart devices. Okay. Here, true means smartphones is a subset of smart devices. All these elements are in smart devices. Similarly, you can also check if a set is a superset of another. So let's just do the opposite. Devices is superset smartphones, and it also returns true. To check if two sets shares no common elements, use the disjoint method. Okay, let's put in the last two examples. So let's see, domestic animals, disjoint, wild animals. Is true because there are no common elements between these two sets. Okay, that's pretty much I have covered in this video. And sets are the last of the collection types in Python I've talked about in my videos. In my next video, I'll use a backend program for selecting data for frontend as an example of how to integrate all the Python data types introduced in my videos so far. Stay tuned. Thanks for watching. If you like this video, please just tap or click that like button, and welcome to subscribe to my channel for more interesting Python stuff. Talk to you in my next video. See ya.